to be the premier platform on which open source innovation occurs. He's totally disillusioned, but he has to convince himself of that because it's basically a prime directive for him. He's trying to engineer tipping points because the innovation comes from the developers, and the developers also spread the word of your software, and that's basically like the main rule of tipping points, is getting the people involved. So when Steve Ballmer runs around stage saying developers, 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 and I try to like apply that to Asterisk, I have to first help define what an Asterisk developer is. And a lot of people think that an Asterisk developer is someone that writes code for Asterisk and submits it. An Asterisk developer is a user of Asterisk, like Otto, for example. And an application isn't what you think. And this is where I come to Mark's talk and his list of the applications. These are systems. They're Asterisk systems, not applications, because you can't share them with other people. And to reach a tipping point, you have to be able to share code. They're not etc/asterisk files. They're a whole host of other databases and custom glue code written in many different programming languages through various hooks of Asterisk and mini config file generators, and basically you have to create a Linux distribution that runs your software. And for that reason, they're systems. An application would be the Q game that Mark mentioned being distributed as a simple like component of someone else's application, and therefore they can just plug that in and people can all use that software. So the configuration grammars have evolved from being this configuration file to a general purpose programming language. And it's not a general purpose programming language, though it kind of needs to be. One must acknowledge that the extensions.conf file actually is software. And I think this point especially is where a lot of people disagree. When you write extensions.conf, you are absolutely writing software, despite that .conf extension. And that .conf extension has to change because they think that they're configuring the system, but they're totally writing a state machine that is code.
It was for configuration.
It was, yeah.
It into a language, that's why we have AEL now.
Yep. Well, AEL still has some problems.
But the language.
Yeah, a little bit. I'll go into that in a second. So even with extensions.conf, people can't, and the other config files, they can't write those Asterisk systems because everything depends on each other. And at this point, they drop down into sysadmin skills to put together something. And they lose the benefits of actually creating an application. A system is much less distributable, and an application is something that everyone can use. For example, if SwitchFox were simply a series of dial plans and the web interface, they could both talk to each other and share state among clusters and allow people to extend it very easily and so forth. And in the Asterisk systems, all these third-party scripts are second-class citizens because over AGI, for example, a lot of things actually in the code go to extensions.conf to see if some particular priority exists, like the failed priority. Does that exist in the dial plan, extensions.conf? No, it doesn't, so I'm not going to do this code. But that code could be used over AGI. And there's tons of those little hooks that I've encountered as I wrote Adhearsion. So Asterisk is still fundamentally structured around this extensions.conf grammar, which is fundamentally flawed. So how many of you guys have heard of the long tail? It's like 100% applicable to the voice over IP scene and voice in general and the voice application concept, because all of these examples that Mark gave, and basically all of the uses of asterisk in the market are people trying to build these verticals along the long tail. And asterisk was pragmatically designed to cater to the big head, which is totally acceptable. The big head is basically PBX among a couple other things. But that design decision prevents people from trickling down the long tail. And that's needed to reach a tipping point. So what asterisk developers would like? Code sharing is absolutely crucial. Things don't spread like wildfire if people can't reuse others' code. You can't take extensions.conf and send it to your friend and he can just like plug it right in. He has to like mess with like priority numbers and mess with context names and mess with go-tos, because all that starts mess with sip.conf entries. Everything is so intermingled that people can't reasonably share code. The use of a real programming language. Whenever you write software with extensions.conf, you're basically using what was intended to be a general purpose programming language, but it isn't. And code sharing would be a heck of a lot easier if you had a real programming language, because people could create libraries, they could create bigger abstractions, they could integrate with things better because of libraries that already exist. This goes back to code sharing. They could make money writing applications because things would be easier to do, and therefore they could serve more customers. Developers absolutely need accessible atomic telephony building blocks, which is something that separates all of the tiny building blocks on which telephony applications depend into an API that is executable through various ways. And I'll talk about that in just a second. Clusters are absolutely another thing, and by having atomic telephony building blocks, you could create abstractions which allow you to cluster applications much better. The difficulty in creating these applications and what's required for them is, firstly, identifying the atomic building blocks and reliably implementing them. And for this, every asterisk application would have to be rewritten to use the telephony building blocks. And that's a ton of work. For example, voicemail. If voicemail were implemented in something that compiled down to, say, C, and then ran what is effectively there now, the like C representation of the voicemail system, someone could go to that higher level abstraction and then modify it for other languages. That came up earlier today, where people couldn't use voicemail at all because the grammars weren't supported in the voicemail baked into asterisk. But if there were higher level abstractions of voicemail that used these telephony building blocks, people could extend it just beyond like natural language grammars. They could write, I ran into the issue of sending emails and asterisk and how you can only specify one email address. Well, I wanted to send it to an entire group, so I had to create like a sendmail server, which like wrote alias files dynamically and like sent to all of the people. And I had to send it to like sales at localhost. So I could have dropped down, or I could have dropped up, I guess, to a higher level abstraction of voicemail and made changes to it directly. And this is something that I think is extremely valuable. If queues and agents, for example, were rewritten with something that simply used these telephony building blocks, people could come in and fundamentally alter how queues and agents worked. The example Mark gave about having games during the music on hold could be done with perhaps a component that simply plugged into into like the higher level abstraction of how someone is put in the waiting state, for example. I say that execution is transport independent in reference to the telephony building blocks, because some things are totally not embeddable. For example, if you were to write an application in Java, well, you can't embed Java inside asterisk at all. So instead of having the telephony building blocks be